Hello everyone, today we are diving into the most powerful, most luminous, and most unfathomably violent explosion ever recorded in the 13.8 billion year history of the universe, a cosmic cataclysm so bright that it temporarily blinded nearly every gamma-ray telescope in orbit, so energetic that it outshone every previous stellar explosion by more than 50 times, and so rare that scientists estimate it only happens once every 10,000 years. This is not a supernova, not a neutron star collision, not even a typical gamma-ray burst. This is Gray B 221009A, officially nicknamed the Boat, the Brightest of All Time. For decades, we have studied gamma-ray bursts as the universe's most extreme fireworks, the final, catastrophic death cries of the largest stars, or the violent merger of the densest objects in existence. But nothing, in more than 50 years of observing these blasts, has prepared us for what we detected on October the 9th, 2022. On that day, a pulse of the highest energy light in the cosmos tore through our solar system, raced past every planet, and washed over Earth, leaving a faint but measurable mark on our upper atmosphere, even from 2.4 billion light-years away. Let that sink in. A single explosion, halfway across the observable universe, was so intense that it reached out and touched our planet, a tiny blue speck in the cosmic ocean. To understand why the Boat is more than just a record-breaking event, we first need to step back and grasp what gamma-ray bursts actually are, and why they hold the title of the universe's most powerful explosions. Gamma-ray bursts, or GRB-Bs, are brief, blinding flashes of gamma rays, the most energetic form of light, millions of times more powerful than visible light, that appear randomly in the sky, last from a fraction of a second to several minutes, and vanish just as quickly as they came. They were first discovered, accidentally, in the 1960s by US military satellites monitoring for nuclear tests, and for years no one knew whether they came from our own solar system, distant galaxies, or somewhere in between. Today, we know they are cosmic events, born from two of the most extreme processes in stellar physics: the death of a star, 20 to 30 times more massive than our Sun, or the violent merger of two neutron stars, or a neutron star and a black hole. Long-duration GRB-Bs, the category the Boat falls into, begin when a supermassive star runs out of nuclear fuel. Without the outward pressure from fusion to counteract gravity, the star's core collapses inward in a fraction of a second, crushing protons and electrons together to form a neutron star, or more often, a brand new black hole, the ultimate point of no return in space. As matter spirals into this newborn black hole, at nearly the speed of light, it forms a superheated, spinning disk, called an accretion disk. Fierce magnetic fields twist and channel some of this infalling material into two narrow focused jets that blast outward from the black hole's poles, piercing through the star's outer layers and racing into space at 99.99% the speed of light. These jets are not just streams of gas. They are focused beams of pure, unimaginable energy, carrying gamma rays, X-rays, and high-energy particles that can cut through interstellar gas and dust, like a laser through paper. We only see a GRB when one of these jets happens to point almost directly at Earth, turning a distant stellar death into a brief but blinding beacon in the sky. For years, GRB 130427A held the record as the brightest and most energetic burst ever detected, a monster that astounded astronomers with its power. Then came the Boat on October the 9th, 2022. NASA's Neil Gehrels Swift Observatory and Fermi Gamma-Ray Space Telescope picked up a signal so intense that it saturated their detectors, meaning the blast was so bright that the instruments could not measure its full strength. Like staring directly at the sun with a camera designed for moonlight. Astronomers around the world dropped everything, mobilizing every available space, telescope, and ground-based observatory to chase this unprecedented signal. Chinese missions, including the Insight-HXMT Eye of Heaven satellite and the GECAM-C Extreme Vision Telescope, delivered some of the most precise measurements ever taken of a GRB, revealing that the Boat was not just brighter, it was exponentially more powerful than any burst before it. Let us put its energy into numbers that we can almost comprehend, even if our minds can never truly grasp the scale. In just 7 to 10 minutes, the Boat released more energy than our Sun will generate over its entire 10 billion year lifetime. Its peak luminosity clocked in at more than 2, multiplied by 1047 watts, a figure so large that it dwarfs the combined light of every star in our Milky Way galaxy, thousands of times over. Some calculations suggest that if this burst had occurred just 10,000 light-years from Earth, its radiation would have stripped away our ozone layer, irradiated the surface, and wiped out nearly all complex life in a single, devastating pulse. Thankfully, the boat was safely 2.4 billion light-years away, far beyond the reach of its destructive power, but close enough, by cosmic standards, to give us a front-row seat to the most extreme physics in the universe. What makes the boat even more extraordinary is not just its raw power, but the unique details it revealed about how gamma-ray bursts work. Most gray bees have wide, relatively unfocused jets, but the boat's jets were incredibly narrow, just 0.8 degrees wide, narrower than the moon appears in our sky, making them far more focused and intense than any previously observed. This narrow beam is why the burst was so bright. All its energy was concentrated into a tiny cone, like a flashlight, compared to a light bulb. The boat also produced gamma-ray photons, with energies up to 18 tera-electronvolts, more than twice the energy of particles, accelerated by the Large Hadron Collider, the most powerful particle accelerator on Earth. For days after the initial blast, astronomers tracked its afterglow across every wavelength from gamma rays and X-rays to visible light, infrared and radio waves, watching as the jets slammed into interstellar gas and slowed down, painting a detailed picture of how these cosmic explosions shaped the space around them. Even Earth itself felt a subtle effect. The boat's radiation disturbed our upper ionosphere, creating electrical disturbances that lasted more than 10 hours, an effect no other gray bee has ever produced at such a vast distance. This event is not just a curiosity. It is a scientific revolution, packed into a 10-minute explosion. For astrophysicists, the boat is a once-in-a-lifetime chance to test our theories about black hole formation, relativistic physics, magnetic fields at their most extreme, and how heavy elements like gold, platinum, and uranium are forged in the heart of stellar explosions. Every grebe seeds the universe with heavy elements that eventually become planets, moons, and even the building blocks of life, and the boat's unique properties are teaching us how these elements are spread across galaxies. Before the boat, we thought we had a solid grasp of how bright and energetic grebes could be. Now, we know our models were incomplete, too conservative, unable to account for the true limits of cosmic violence. The boat has forced us to rewrite textbooks, adjust our simulations, and ask bigger questions. What kind of star could produce such an unimaginable blast? How do its magnetic fields become so strong? How common are these superbursts in the early universe, and did they shape the first galaxies? It also reminds us of the fragile, awe-inspiring balance that allows life to exist on Earth. We live in a quiet corner of the Milky Way, far from the massive stars that die as gray bees, safe from the apocalyptic blasts that can sterilize entire regions of space. The boat is both a warning and a wonder, a reminder of the universe's terrifying power, and a testament to human curiosity that lets us study these events from a safe distance, unlocking secrets written in light that traveled for 2.4 billion years to reach us. Think about that. The light we detected from the boat started its journey when Earth was still a young planet, long before complex life crawled onto land, long before dinosaurs, long before humans ever walked the Earth. That single pulse of light crossed 2.4 billion years of cosmic history, passing through empty space, dodging galaxies and nebulae, just to reach our telescopes and teach us something new about the cosmos. This is the magic of space exploration. We do not just study stars and explosions. We study time itself, reaching back billions of years to understand where we come from and how the universe works. NASA's Fermi and Swift observatories, along with international partners like China's space science missions, turned a random cosmic flash into a treasure trove of data that will keep scientists busy for decades. They turned a once-in-10,000 year event into a lesson about humility and wonder. The universe is far more powerful, far more mysterious, and far more magnificent than we ever dare to imagine. As we continue to scan the skies, building more sensitive telescopes and more advanced instruments, we will undoubtedly find more extraordinary events, more record-breaking explosions, more secrets hidden in the dark. But the boat will always hold a special place in the history of astronomy, the burst that showed us we still know so little, and that the cosmos still has endless surprises waiting for us. It is a beacon in the dark, a reminder that every time we look up, we are not just staring at stars. We are staring at the story of everything that exists, written in explosions, light, and the unbreakable rules of physics. The boat is more than the brightest explosion ever recorded. It is a celebration of human ingenuity, a window into the most extreme corners of the universe, and a call to keep looking up, keep asking questions, and keep exploring the infinite, awe-inspiring cosmos that surrounds us all. Please like, comment, share and subscribe to the channel.